All right, we're working on Algebra 2 with Trig, Unit 3B.2a. Add and subtract rational expressions. So when we add and subtract fractions, we of course need common denominators. So when the denominators are the same, it's pretty simple. You just are adding or subtracting the numerators. So in this case, we get A plus B divided by C. If we have x's, as long as the denominators are the same, we know that the common denominator is going to be 5x squared. That's the common one. The top, since those are unlike terms, those just get added together. We cannot call that 10x. We have to keep it separated because the 7 is not an x term also. Our common denominator with the a minus the b, or in this case, our common denominator with 9x cubed minus x squared. We cannot subtract those. You cannot say that that is 9x. Those are unlike terms. They don't have the same x degree. Just like in a quadratic, x squared plus 3x, we don't combine those together. We don't combine it here. So we're going to add our two fractions together. If they have common denominators, life is very good. These are like terms. We can add those together. These can be reduced. And we get 4 over x. Here we're subtracting. We're going to have common denominators. We're going to have our 4x minus 7, and we're going to subtract. Now be careful here. You're going to subtract the entire 3x plus 3. So you have to use parentheses because you have to subtract the 3x and you also have to subtract the 3. So that's going to turn into 1x and negative 10. Now, from what we learned yesterday, we cannot simplify this. The x's do not cross out. The 2 does not go into the 10 5 times. You cannot simplify that. Because the 10 is being subtracted or added for that matter, you cannot separate that. Only by multiplication. Okay. So now you take the opportunity to come down and calculate these out. Pause the video, answer those, and check your answers. So we look here and we see common denominators. So we say 3x squared and 4 minus 1 is 3. We can reduce here because there is no adding and subtracting between terms. It's only multiplying between terms. So this becomes 1 over x squared. On this side, we have a common denominator of x squared plus 1. And we add our like terms together. But we might notice that this is x squared, or 2x squared plus 2. It has the same terms in it. So we can bring that 2 out, and you're left with an x squared plus a 1. And that happens to match the denominator. So those are going to cross out completely. You would not be able to cross just the 1's out, but because it's the whole quantity, not just part, because of the plus, we often say you can't cross out because of the plus. In this case, because it's the whole quantity, they can cross out, and you're left with the answer of 2. Now, if we have unlike denominators, to add or subtract rational expressions, rational meaning fractions, rational expressions with unlike denominators, find a common denominator. Rewrite each rational expression using the common denominator, then add or subtract. So in a situation like this, we have to get the denominators the same. So we have A and C. We need there to be a D on bottom also. So I'm going to multiply this fraction by D over D. I'm multiplying this fraction by a value of 1. And I'm going to multiply this fraction by a value of 1. So what that's going to give us, that's going to give us AD over CD, and that's going to give us BC over order of multiplication doesn't matter, so we can still call that CD. So our common is AD plus BC all over CD. So we had to get the denominators the same to do that. And the same situation is going to be over here. We're going to multiply by whatever is going to make it a common denominator, and then multiply by whatever is going to make it a common denominator. Now the denominators have a CD for both of them. This isn't plus, this is actually minus. So our final answer is going to be AD minus BC all over CD. Okay, you can always find a common denominator of two rational expressions by multiplying their denominators. However, if you use the least common denominator, called the LCD, least common denominator, which is the best common, which is the least common multiple of the denominators, there'll be less simplifying to do. So what they're saying here, one option is always to do like we did up top. Because I didn't have a D, I don't have a 4 in this one. I'm going to multiply by 4 and 4 plus 1/4. I don't have a 6 in this denominator, so I'm going to multiply by 6 and 6. That's 4 over 24, and that's 6 over 24. So that's 10 over 24. But because I used numbers that were a little too big, I now have more reducing I have to do at the end. 2 goes into this number 5 times, and 2 goes into this number 12 times. So that is a way to add these two fractions together. Notice I did not use a calculator. You can use your pencil and paper to calculate these out. I did not make decimals. The other way is thinking about your least common multiple. What number do 6 and 4 both go into? They both go into 12. So I need another 2 to make that become a 12. And to get the 4 to become a 12, I need that to be a 3. So I'm going to do 3 on top and bottom. So that's going to give me 2 over 12 plus 3 over 12, and that gave me 5 over 12. And I did not have to do any reducing because I kept my numbers to the least common denominator, not just a common one. Another way to help us determine that 12 is the number we're going to use, because 6 and 4 both go into 12. This is what we're going to look at soon. That is 2 times 3, because that's what makes 6, right? Those are the prime numbers that make 6. And 2 times 2 is what makes 4. So we need to make the denominators the same. All right. So I have 2 2s, but I don't have a 3. So this one needs an extra 3 to go with it. Now it has 2 2s and it has a 3. Whatever I do to the bottom, I also have to do to the top. This one only has 1 of the 2s and it has a 3. It needs another 2. Now it's common. Now it has 2 2s and a 3. 2 2s and a 3. So I can do the rest of the calculations to get 2 over 12 and 3 over 12. So that's a way to help you recognize that we're going to actually be using the number 12. That'll definitely become necessary when we're working with x's. But in this case, if we're using numbers, we can probably just think, what does 6 go into? 6 goes into 6. 6 goes into 12. 6 goes into 18. 6 goes into 24 and 30. 4 goes into 4, goes into 8. Oh, it goes into 12 also. So that's why that was the lowest common denominator they both went into. It's called the least common multiple. So on the flip side, now we're going to start looking at it a little bit more complicated when we're talking about x's. So just like we got done talking about, we're going to do the steps for adding and subtracting if we have unlike denominators. All right, so First, we've got to find a common denominator. We're going to look at each of the terms and multiply the top and the bottom, the numerator and denominator, by the what's missing term, like I showed you in the previous problem. We're going to rewrite these, and we're going to distribute in the numerator. And we're going to leave the denominator factored. The reason we're going to distribute in the numerator is so that we can add and subtract. So let's give this a try. All right, hang in there. It looks a little crazy. So the first thing you want to do is factor apart. And it might be helpful to really break it all the way down into the prime numbers. Okay, break it all the way down. So 2 times 5 makes 10, and your x squared. Here I can factor out a 5, I can factor out an x, and then I also would have an x minus a 2 left over. All right. So now we have to look at what things have and what things don't have. So they both have a 5, so we don't have to worry about that. What this doesn't have an x minus 2. This denominator doesn't have the x minus 2, so we have to multiply the bottom and the top by that missing term for the denominators to be the same. Now let's look over here. I currently have a 5x and an x minus 2. What is missing? Well, this one has an x squared. This one only has an x. You can't use the x squared inside the parenthesis. You can't go in there to get your x squared. So this is your x squared. This only has an x. So I need an x for the top and the bottom. Now I would have an x squared, a 5x squared. I also need a 2. Some people look at this and they say, well, you have a 2. It's x minus 2. No, that's its own quantity. You just need the number 2. So I'm going to multiply the top and the bottom by what is missing, which is a 2x. Now it said that we would collect like terms, and we're adding it to positive 4x squared, and our denominator is going to be 10x squared x minus 2. So we might want to rearrange that a little bit. And there we have our crazy answer. Okay, we're going to come over here to our second one. The first thing we do is factor apart what we can. Factor your denominator apart. For the numerator, you could factor it apart, but not necessary. So this looks like it's x and 5 and 1. two numbers that multiply to be 5 and add to be 4. It's going to be 4 if it's a -5 and a +1. Now, when you look at these denominators, you see things in common. You see x minus 5 and x minus 5, so those are good. This one over here does not have an x plus 1. So this needs an x plus 1. This one on the right does not have a 3. So this is going to need a 3. So if you have it written, this is how you would probably do your homework. I'll just rewrite it a second time. You probably wouldn't write it a second time. This one was missing what term? This denominator doesn't have an x plus 1. So I'm going to do that to the top and the bottom. This one does not have the 3. So I'm going to do it to the top and the bottom. Distribute this in, and you get x squared plus x. Distribute this in, and we get 6x plus 6. Now you've got to be careful because you're subtracting. If you're subtracting, you've got to subtract both of those terms. X squared minus 5x, that's a -6 and a +1, and a -6. And I would have a 3, an x minus 5, and the x plus 1, all in the denominator. Now, when you think about factoring this guy apart, this is going to factor apart as -6, -6 plus 1, perhaps. Let's take a look at that. All right, so it looks like this is factorable. And I'll show you what we could have done earlier. We talked about it, didn't catch it. All right, this guy here is x minus 6, x plus 1. This is still 3, x minus 5, x plus 1. Those can cross out. So your best answer is actually this. That's the most simplified fraction. Now, how could we have seen that coming? So this isn't really the answer. I had to do some simplifying. Where could we have seen that from? Well, up here from the original problem, if we talked about factoring that out. If we would have factored that out, we could have reduced it from the very beginning and never had an x plus 1 involved. That would have made the problem a little bit easier. So just something to keep your eyes open for, but as you saw, it was not a requirement. You can take care of it at the end. All right, so let's come over here. You go ahead and try these. You can pause it, try them, and then check out your answers. All right, so if you notice, these are both even numbers. So you might want to consider just working with the fractions that were given. They have some terms in them that can reduce it and make this problem so much easier. Over here, we have 2x up on top, and the bottom is a 5x, which would give us x plus 1. So if you factor out a 5x, you're going to be left with x plus 1. Your x's can cross out, and that's going to be really helpful. So now you're actually working with the problem 3 over 5x squared plus 2, 5 times x plus 1. They both have a 5. This one does not have x plus 1, so the top and bottom need x plus 1. This side, what is it missing? It's missing the x squared. So we're going to get 3x plus 3. And we're going to get to 2x squared. And our denominators both have a 5. They both have an x squared. They both have an x plus 1. So if you want to write that one kind of in a standard format where your largest exponent is first, okay, because we did the reducing ahead of time, we don't have extra terms left over. So we're going to come down here to our last one. We factor, remember the first thing we always do is factor the denominators apart. Just take your time, have plenty of room. So we factored that apart. This problem is automatically going to be more difficult because it's a subtraction problem. More people make mistakes with subtraction problems. Let's see what we have here. We have x and x. We have 2 and 1. They have to be the same sign because it's a positive 2, but they have to be negative to get up to 3. So it looks like there's no reducing I could do. So this side needs a 4 to the top and the bottom, and that looks like it. This side needs the x minus 2 to the top and the bottom, and that looks like it. So here we're going to get x squared minus 3 and minus 2 gives us minus 5 plus 6 minus a negative 20x minus 8. And that's all over our common denominator of 4, x minus 2, x minus 1. All right, this is a positive 20 and a positive 8. X squared, positive 20 would give us 15x, and a positive 8 would give us 14. That kind of looks like it's factorable. What multiplies? So if we wanted to consider factoring that, that would be x plus 14, x plus 1. But when you look at it, that doesn't help us reduce anything because it's a plus 1 on bottom or a minus 1 on bottom, and it's a plus 1 on top. They do not reduce. Nothing to reduce. So this is actually your best answer. All right, I understand this is crazy. It just takes a little practice. You've got to show your work. Don't be in a hurry. Good luck.